Applying image captioning techniques to New Yorker cartoons presents a unique challenge: generating captions that capture the wit and humor of winning entries in the Cartoon Caption Contest. This task demands sophisticated visual and linguistic processing, as well as an understanding of cultural nuances and humor. To address this, the authors propose novel baselines for using vision transformer encoder-decoder models to generate captions. Cartoons pose distinct challenges featuring abstract, stylized representations and complex narratives that deviate from the concrete objects and scenes commonly found in image captioning datasets. The authors highlight the importance of considering these differences when applying image captioning techniques to cartoons. The paper builds upon related work in image captioning, including the use of transformers and vision language models. These models have shown promise in generating coherent and descriptive captions, but the authors argue that they must be adapted to accommodate the nuances of humor and common sense. The proposed approach leverages the strengths of vision transformer encoder-decoder models, which have proven effective in image captioning tasks. By fine-tuning these models on cartoon datasets, the authors aim to generate captions that not only describe the visual content but also capture the humor and wit of the original cartoons. The success of this approach hinges on the model's ability to understand and generate humor, a complex and culturally dependent concept. The authors acknowledge the challenges of replicating human humor and highlight the need for further research into the role of common sense and cultural knowledge in AI systems. Researchers are refining AI approaches to better understand and engage with human communication nuances, focusing on the New Yorker Cartoon Caption Contest. This contest requires humorous captioning that transcends pure information content, making it a challenging task for AI systems to grasp subtle cultural and contextual nuances. The New Yorker Caption Contest dataset is utilized, consisting of cartoons and corresponding metadata, including human annotated descriptions, explanations for humor, and relevant entities. The dataset comprises approximately 2.6K data entries, with train validation test splits similar to those in previous research. To tackle this task, multimodal vision encoder-decoder models are employed to generate captions from cartoons alone, without relying on human-labeled metadata. This approach mimics the creative task of determining which aspects of the cartoon to satirically emphasize, a key aspect of the New Yorker Cartoon Caption Contest. 8 different training pipelines are outlined, leveraging Hugging Face and PyTorch libraries. Notably, previous research has explored this area, achieving superior performance in matching and quality ranking tasks using GPT-4, but struggling to explain jokes as well as humans. The authors suggest that there is room for further exploration in generating humorous captions, particularly in the context of multimodal humor understanding. This research aims to address the limitations of current AI systems in grasping subtle cultural and contextual nuances, paving the way for more sophisticated human-AI communication. The paper presents a novel approach to generating captions from cartoons using a CLIP GPT-2 encoder-decoder model. This model leverages the CLIP vision transformer to map input cartoons into a multimodal embedding space, which is then decoded by GPT-2 to produce captions. The authors propose 2 distinct formulations, one focused exclusively on caption generation and another that incorporates metadata. Additionally, the paper explores the application of Llama-ANEXT models in 0-shot and 5-shot settings for caption generation. This highlights the model's capacity to generate captions without or with minimal examples. The authors provide detailed descriptions of the experimental setup and results, including the use of specific prompts and the evaluation of the model's performance. This research contributes to the field of image text generation, demonstrating the potential of transformer-based models in generating descriptive captions from visual content. The findings underscore the importance of multimodal learning and the flexibility of these models in adapting to different tasks and settings. The authors investigate 2 techniques to augment language models' performance on logic, calculation, and decision-making tasks. Firstly, they employed chain of thought (COT) prompting, a prompt engineering technique that structures the input prompt to simulate human reasoning by providing a series of intermediate reasoning steps to encourage more sophisticated decision-making. This is illustrated in Figure 5. Next, they fine-tuned the LLAVANEXT model using low-rank adaptation, LoRa. A popular fine-tuning mechanism that reduces the number of trainable parameters without sacrificing the benefits of downstream fine-tuning. LoRa approximates updates to weight matrices with a low-rank matrix decomposition, delta W approximately equals BA, where the original weight matrix W0 is frozen, and only A and B are trainable parameters. To further optimize memory usage, they also implement quantized LoRa, QLORA, and loft-Q initialization. The LLAVANEXT model is fine-tuned end-to-end on an A180 GB GPU for 10 epochs with an R value of 32, learning rate of 1E4, and alpha of 16 on all linear layers. The authors repeat the evaluation using the GPT-4V multimodal model with both 5-shot and complex COT mechanisms, utilizing the OpenAI API to query GPT-4V. The same prompts are used for the evaluation of LLAVANEXT. Automated evaluation metrics, such as blue and rouge scores, are used to compare the generated captions to human-written captions, in addition to manual quality examination. Notably, all models perform poorly with respect to the blue score metric, which is designed to evaluate the quality of text from one natural language to another. Page 5 of the research paper presents generated captions for the New Yorker Caption Contest 54 using various models, including GPT-4V, LLAVANEXT, and CLIP-GPT-2. These captions demonstrate the model's ability to understand humor and generate witty responses. Figure 6 displays the generated captions, with the winning caption being, "And, when you get hungry, the cafeteria is to your right, left, left, right, left, straight, left, and then you push on the big lever." The authors acknowledge that automated metrics, such as rouge scores, do not accurately capture the performance of these models in this task. Figure 7 shows the rouge scores for each model, with the CLIP-GPT-2 model performing best. However, the authors argue that these metrics, designed for machine translation and summarization tasks, are not suitable for this use case. To address this limitation, the authors propose a manual quality evaluation metric called SSSCORE. This metric involves comparing machine-generated captions with each other, using the human-written caption as a reference, and selecting the best machine-generated caption. The quality of the generated captions is evaluated based on 3 criteria: descriptive information about the cartoon, conveying humor or wit, and addressing similar themes as the winning caption. The authors tally the statistics for each model by calculating the number of times it generated the best caption, normalizing by the total number of test examples, and obtaining a proportion that is equated to the SSSCORE. The SSSCORE metrics are presented in Figure 7. The discussion highlights the limitations of automated metrics and the importance of manual evaluation in this task. The authors evaluate their cartoon caption generation models, criticizing automated metrics like blue and rouge for lacking semantic meaning. They employ SSSCORE for manual quality evaluation, finding GPT-4V performs best, especially in the 5-shot setting, demonstrating few-shot learning and adapting to high-quality captions tone. A qualitative evaluation showcases generated captions from GPT-4V, CLIP-GPT-2, and LLAVANEXT. CLIP-GPT-2 mimics the tone but struggles with semantic content, while LLAVANEXT tends to generate titles, improving with fine-tuning. GPT-4 stands out for understanding style and tone, incorporating sociocultural nuances and current events. It's the current state-of-the-art model. Future directions emphasize enhancing AI models for humorous and contextually relevant captions. This research paper presents a thorough assessment of several models for generating humorous captions for images, utilizing metrics such as Rouge 1, ROUGE 2, Rugal, and SSSCORE. The LLAVANEXT model with chain of thought, COT, prompting stands out in producing high-quality captions. Future work could involve training larger models like GPT-5, distributed training, refining prompt engineering, and curating additional datasets with a broader range of cartoons and comics. The importance of hierarchical prompting and collaboration with cartoonists and humorists to annotate datasets for better model training is highlighted. This study builds upon previous research on enhancing image captioning, understanding visual humor, and efficient fine-tuning of quantized large language models, aiming to advance the field of humor generation in AI through novel methodologies and evaluations of state-of-the-art models. This section of the research paper presents a comprehensive list of novel methodologies for data analysis, focusing on the application of advanced statistical techniques to improve predictive models. The methodologies are designed to address the limitations of traditional approaches by incorporating machine learning algorithms and Bayesian inference. The authors emphasize the significance of these methods in enhancing model accuracy and robustness, particularly in complex datasets.